Wow. Are you sure you're in the right track, the right session? I'm surprised. I mean, usually I'm off going home by this time. So I'm happy that you're still here. Event sourcing, yeah. Just to check, like, how many people actually know about event sourcing? Ooh, how many actually have used it, built a system, production, maintained it? Yeah, see, usually there's a couple of hands left. That's good. Then at least I have something to tell. My name is Dennis Doomen. I'm Dutch, as you obviously can hear. Yeah, I've been doing this for a long time, like 28 years, a little bit more now, almost 3 decades. That sounds very old. I'm 51, so yes, I am quite old, although if I look at the audience, not too bad. I work for a small consultancy firm in the Netherlands, Aviva Solutions, and I'm an MVP, Microsoft MVP in developer technologies, which has nothing to do with, with the topic of today. I do a lot of stuff. You may know me a little bit from this open source project called Fluent Assertions, but I have a bunch of other projects. I'm working on new things. I blog. I spend a lot of time sharing everything I know, everything I learn, and everything I have opinions about, which is quite a lot, actually. So event sourcing. I assume, because not everybody, or only a couple of people raised their hands, that I have to go through the basic details. We have only 45 minutes, which I can use to, dump a lot of information, but I also want to make sure that you don't fall asleep after this full day. What is event sourcing and why is it cool? This is actually a loaded term. You have all these things you learn in your career, like Git, Docker, that really change the way you do things, right? They really change the way you do software development. There's also a lot of stuff that's completely overhyped, like microservices and stuff. Event sourcing, which I thought was kind of mainstream by now, apparently it's not, because I see all these people sitting here. But for me, to be really honest, and I don't want to spoil the whole presentation, for me it's just a pattern. I mean, you all know the design patterns, right? Is anybody old enough to have the white book, the Gang of Four book, on their desk, waving around to your colleagues like, look, I've checked all the patterns, just to check. And I want you to be honest. Did anybody ever use the visitor pattern in practice? Oh, really? You guys have built some really awesome stuff. Must be. So for me, event sourcing is an architecture style. Something that you need to be aware of, you need to understand the pros and cons, and that's it. Really? Yes. I started practicing it since 2013. I actually learned about this from Greg Young. Maybe you've heard that term before, or that person. It's not a term. Which introduced me also a little bit in the domain-driven design world. I've spoken about this topic a lot. So let's show you what it is. So I have an app, beautiful little app, Vue.js, React, Maui maybe, which sends commands. Commands are typically things in the domain, in the business domain. If you have done any domain-driven design, you may have heard the term ubiquitous language. That's kind of what they want you to do. They represent something that happens in that particular domain. That command is handled by, I don't know, an HTTP API. I don't like to call them REST APIs, which process that and then finds a command handler. If you were in the previous presentation, you saw media.tr or mediator is often used here. But this thing is responsible of figuring out, okay, we're actually doing something like a client moved, or the address was corrected, or an order was approved, or an order was rejected. These are terms from that particular domain, and the command handler is responsible for figuring out what are the business rules that need to be applied there. The next step is the domain model, the entities. If you know the DDD terminologies, you'll be talking about aggregates and aggregate roots and value objects and stuff like that. Any DDD practitioners here? A couple of people. So I'll stop talking about that. What most .NET developers now expect is underneath this domain model is entity framework. And if you're old enough, you may have heard of an Hibernate, which I love to use. No, that's a big difference. What we're storing here is not a representation of an entity. Let's say there's an order in that domain. You're not storing the order as in an order table. What you're storing is the actual things that happened on that particular order. An order was created, bad term. An order was, what do you do with orders? Submitted. That's what people do. The order was approved. the order was like a product was added to the order, stuff like that. That is what we store in this event store, and we call them events, also called domain events. This is not exactly the same as events in a message bus or something like that, or an event bus. These are usually things that also use this infamous ubiquitous language. So you'll find things like the order was approved, and with all the relevant information. So we're not storing an order, we're not storing a customer object in a table, we're storing what has happened to that system, if that makes sense. Eventually, they're stored in a database. Can be a relational database like SQL Server, can be Cosmos, can be a NoSQL solution like RavenDB. It doesn't matter. It's just one big table of all the events that ever happened inside that domain. That's what event sourcing is. That's where the name comes from. The source of the domain are the events. The source is not a relational database structure where we use an ORM. It's the events. Okay. What else? On the other side of the picture, you need to probably query data. So in this case, I've built a simple HTTP API, and I have something that will list or subscribe to all these domain events and try to project them, basically take those events and create a representation in the database, in a query store. We call them query store. Can still be a database, a relational database or something else. We create a representation that is optimized for querying. There's another name for this pattern, by the way. This is a combination of two architecture styles. Does anybody know what the other style is? CQRS, Command Query Responsibility Segregation, which is the architecture version of CQRS, Bertrand Meyer's Command Query Separation Principle. So what we're doing here is essentially acknowledging the fact that the left and the right world, the write side and the read side, they're always in conflict. There's always, constraints. Has anybody tried to debug performance issues in a database, in a SQL database, in their life, like analyzing clustered indexes, using Ask Brent to figure out why this index is not performant enough, and why you can solve the performance issue with another index to the database? The thing is, because indexes are actually expensive. They make reads faster, but they make writes slower. So you always have that problem. Or maybe this mismatch in your domain because you're storing your domain using anti-framework in a database, and then you have again that mismatch between protecting what they call the invariance in the domain-driven the DDD world versus getting efficient queries. CQRS tries to acknowledge that. And that's really cool because there's a lot of cool things you can do with this architecture style. Yes, so for example, you can actually take the domain model, the events, and replay them in a way so that you can actually reevaluate all the domain rules. Business rules change. My product owner changes the rules every day, every week, and then we do a PI planning, safe, I hate that. And we put everything on stone, on the plan. The coming 3 months, this is what we're going to do and deliver. And then the next week, the PI, the product owner comes in and wants to change everything. So you can actually replay and change the rules and see different results. This is also great for unit testing. You can actually take this site, build unit test that verify, given this command that comes in, what are the events that come out of that? It's very nice. It's almost like you have a natural architectural boundary. And I like to align my unit tests with the internal boundaries of my code base. This is really good. This is a good way to support that. You can actually test your projectors in a completely independent way. There's so many things I can say about it. I don't explicitly use different colors, but if you're building entities with anti-framework, as an example, how do you go from one entity to the other? With this property, right? You just go to the property in C#, and then magically your ORM will load the relationships between them, which is, by the way, a source for a lot of performance issues. You cannot do that anymore. You actually have to think like what entity are going to become what they call an aggregate boundary. What are the entities that together are representing something that is stored in the event store and belong together? And that's a pretty hard thing to solve. You really have to understand how the system works together, which, by the way, is a good thing. To talk with the product owner, trying to understand all the invariants in your code base, it's important. Has anybody done event storming? you know, with all these post-its on the wall. It's a beautiful technique to, you know, get a more thorough understanding how the business works and thinks, especially if you're talking with different people from different departments. They may actually use the same term and mean something completely different, or maybe use two different terms for the same concept. Event sourcing aligns really well with event storming, because the end result of event storming can be that you have a bunch of events with the terminology they use. Again, ubiquitous language. That's fine, like merging. I'm going to show you a slide after this. Most systems these days use optimistic concurrency. You know, you just try to make a modification, and if somebody else made a modification on the same entity, for example, you just gave an exception, like another user changed that. With event sourcing, you can actually take individual events and try to, merge them together in a more functional way. I'll show you in a minute. Bugs, not always trivial. I'll show you that as well. Yeah, this is also cool. Given the fact that this event store will contain everything that happened functionally in the history of that system, in the order that it happened, it's a really awesome way to figure out why a particular bug happened. Because you can see, and you can literally, if you look at the event store, replay everything that happened in that order until the bug that happened in production pops up. And we've done that. I've used that many times to figure out, like you get this weird bug report, you have no clue what happened, but you can actually see what happens. Because a normal database usually is just, you know, it's the database, it's the current state of the system. Yes, you may have some automatically generated audit tables, but that's just the data. You can see what data changed, but you don't see what was the intent. And with an event store, you have the intent. You can actually see that, I don't know, somebody set a signature on a financial page, a financial document. A person left the company. Somebody else took over responsibilities. If these are concepts in your domain, there should be events as well. And then you can use that to figure out what's going on. Has anybody used that in the past to figure out, use event sourcing for that? It's really awesome. Thank you. Versioning, you know, events will change over time, since they're basically classes. So you have to deal with all these versioning issues. Events may be split. I have a couple of examples later on. Yeah, if you look at this picture, who actually feels like, oh, this is quite complicated, just to be honest, compared to what you see? Who actually believes like, okay, this is just a different way and it has the same kind of complexity? Okay, and the rest doesn't have an opinion, doesn't matter. The reality, and I've done this many times, it is new. It will require you to do new things, to learn new tricks, but it's really a shift of responsibility and a shift of complexity. And I've done it many times. And I've trained a lot of developers. We went through the process when we first adopted it. If you know the tricks, if you know the pros and cons, it's not that complicated. But I agree that it feels new. It's perceived as new, which makes sense. Yeah, just like you can replay this whole event store, you basically get auditability for free, which I just mentioned, which is awesome. I already mentioned that. Replication, interesting. I'll show an example later on how we use that. The other thing is, like, databases are usually limited in terms of scalability, right? You cannot scale a database indefinitely. The beauty of this whole separation between the command side and the query side is that this is a different database than this one. This one is optimized for storing the event store, the events in the history. This one is optimized for querying. So you might actually have, maybe for every page in your user interface, you may have a separate projection, which is maybe just a simple table. Then that means they can be completely decoupled from each other. This can be scaled almost indefinitely, especially, and I'll probably mention this later on, if this communication between the two is going to happen asynchronously. So the domain, you know, validates all the business rules, an event is stored in the event store, then the whole chain of command is completed, and then in the background, those projections are being updated. If you do it like that, you can scale it quite well. And I've experienced this myself as well. What more? Yes, projections can also fail, especially if they're asynchronous. You know, then the problem is that sometimes things will explode. And I'll show you some examples later on. It's also much more difficult if you look at an entity, if you go in your IDE and open a class, a customer class, to see the relationships between all the other entities. And by the way, I'll share all the slides at the end. Also, these projections, they change over time. Maybe you need an extra column. Maybe you decided for a new screen that you need a new projection. Again, a projection is just a class stored in a database. If that happens, then the next time you release your new version, you have to rebuild that projection. That will take time, potentially. And there's different ways to make it faster. I don't even know if I can meet it in time, but okay. Yeah, it's always with unit testing. If I have the one part of the system that's being covered with test, and then the other part, you still want to be able to test everything together. So we've done a lot of end-to-end API tests. So we send an HTTP command into the domain, and then verify that all the way at the end. And again, we have the test pyramid, right? You have unit tests for all the small details, and then we have end-to-end test on the HTTP API level, which is in .NET pretty easy these days, to test the whole, everything together. The cool thing is you can use, for example, RavenDB, which has an in-memory representation, or SQLite for that, because you don't need a very complicated database. You don't need joins and views and whatever here. You just want to have a flat structure. That's really cool. I didn't even mention that, I think. All right, great for unit testing. Yes, it's already mentioned. I already mentioned that. So this is an example of an aggregate using some kind of custom-built framework. You basically have just a user class, which apparently is inheriting from some kind of magic base class. And what you can see, the constructor does one thing. It applies an event on itself. That's what it looks like. That's what it is. It's nothing more than that. What does that do? It actually stores that event. And later on stores that in a database, but this is stored in memory. So you're not directly updating properties, in your constructor or formattings, you actually do it indirectly. So in this case, it's applying on itself, and if you look very closely, you can see it has a property called username, which is loaded from aggregate state. What is that? This is, by the way, the method, just to make it fit on the screen, where I change the username. By the way, if you really do DDD, the purist in the DDD community, they will tell you that you should not use terms like create or update or delete, because that's not what the business talks about. They don't create clients. They wish they could, but they don't. Yeah, it's really true. And the purist will really hit you, because if you start using these names, but again, this is just an example. But you can see that the change username, the only thing it does is to make sure, is the username actually changed? And then applies an event to itself. That's the kind of code you will see if you do event sourcing. And there's different versions of how you can do that. There's libraries available. I have a couple of them at the end of the presentation. And this is an event. Nothing special, right? I mean, there's a base class, but you don't really need that. It's just an example. It's just an event it's almost like a POCO, a plain old CLR object, if you know this term. There's nothing else. A lot of libraries actually use records to really emphasize that it's a data transfer object almost, if you know that pattern name. That's what it is. Event source base, yeah, you can see some examples here. There's a lot of code here, which you probably need, but you should probably get it from a framework. Here you can see what the apply does. That's actually interesting. You see at the top, do I have a, no, I don't have it. At the top, you can actually see that the first thing what the apply do is add the event to a collection. This is so that the framework knows, like, what are the events that were applied since I loaded this thing from a database. I update the version, and then I tell the aggregate state, which is the other class that contains all the properties, to do something with the event. Maybe, I don't know, raise some events, even raise those as domain events within a domain. You can go as far as you want. The load, which happens when you load when you load an entity from the database, that happens on the other side. I didn't mention that. It's too much details, but you can actually see what it does. You tell the system, like, okay, this is the version. I have a collection of events. They are loaded from the database, usually deserialized in some form. And then I just tell the aggregate state to process them at startup. So whenever the system loads an entity from the database, it basically loads the entire history of that object and reapplies those events to that object at runtime. That may sound expensive. In reality, it's not that expensive, and there's ways to make it faster called snapshot. I'm not going to mention that. just to get a sense of the kind of code you will see. This is what the aggregate states look like. It's just a stupid class with properties, and you can see this when method. This is where the event is processed and the property is updated. It's a bit of an indirection, and there's different ways of doing it, but this is basically what happens. And this is a projector. Again, you don't have to remember all this code. There's just an example of there can be potentially a lot of things you have to do. And you can look it up later on. So, yeah, there's another example. So if you look at the whole conflict handling, what you see here is two histories. I have the persistent state. This is stored in the event store. I have a couple of events that happened, and they're grouped. Usually they're grouped together in a kind of transactional way. This is the red line represents the point in time where we're now, and then multiple things happen in parallel. Like one is happening on the central system, and the other events are triggered by different concurrent users. Normally, you would get an optimistic exception, optimistic concurrency exception, right? In this case, it's different, because what we will do is the system will basically say, okay, so you're going to be applying a bunch of new events that were triggered by the domain based on a version of that entity. Let's say in this case, it's version 3. So what will happen is it will basically say, okay, what happened since version 3? Well, those are the events on the left side, password changed and role revoked. On the right side, we also have a role granted and a password change. And now what you can do, and again, this is optional, by the way, this is if you need that. You can say, okay, let's compare those two events functionally. And you need the product owner, the business analyst, or whatever to make decisions about that. Is this a functional conflict? Probably not. So it's green. So then the next one, is role granted or role revoked a conflict? Depends. If it's a different role, if you're assigning a particular permission to a particular user and revoke another permission, if it's not the same permission, it's green. It's not a conflict. This is something you cannot do without event sourcing, or very hard. So we put that role granted on top of it. Now the next one, password changed. That is a conflict, potentially, because we've changed the password on both sides of the connection, or two people actually did it at the same time. Is it a conflict? Yeah, potentially. No, it's not. We actually decided that the last one wins. We just basically created a merge class, a bit of logic in C# that actually looks at the two events, knows that a combination of those two are never a conflict. We just assume that the last one wins. That kind of flexibility is very powerful in a system, in a domain where there's a lot of different users working on the same data. And that's also where event sourcing shines. Another example, no, it's not a conflict. So at the end, no conflict, it's just put there on top of it. And then we're done. Now, over time, the domain can evolve. In this case, we have an aggregate root, which is a DDD term, which is basically the entity that is the entry point in a couple of entities that together form a business capability. And what you can do is you can actually take that event store and then over time redesign the actual domain, create new classes, but load the old events into the new domain. And maybe decide that, okay, we had a big aggregate in the beginning, now we're breaking it up in smaller ones because, the business rules change. These are real scenarios if you have big systems like that. Again, you don't have to do that. Now, why did we even adopt it in the first place? We wanted to support this kind of model. We're building a system which has systems running centrally. We had people using laptops, which were occasionally connected because they went in the desert of Australia. They went underground. Sometimes there was 4G or 3G at that time. We were talking about 2013. There was no 5G. There was probably not even 4G. Sometimes it was Wi-Fi. We also had servers running in the cloud, or we had servers running somewhere in Alaska, very close to an oil platform, because this is the business we're talking about. And we wanted to be able to somehow work on data and then distribute the data in a nice way. And we also, by the way, had chips, which also run their own servers there. These days, you could use Azure Arc, I think it's called, but that's the world we lived in. So we looked at different options to support that, like maybe just use SQL Server replication. We were using SQL Server. It wasn't designed for that. It was replication is meant for failover scenarios, not to actually start synchronizing all kinds of different machines together. We also looked at command serialization. If you remember correctly, at the beginning, I send a command into the system. You could say, if you remember, create a list of commands, pass them to the other server, let them replay the commands, then you get the same result, right? Well, not entirely, because commands can actually, depending on the version of the code base that's deployed, it can have a slightly different effect, and we didn't want that. The command is not the same as the output, as the outcome. Another thing is maybe you can serialize the entire entities, in some form, JSON, and send that over the wire. Yes, we consider that, but then you have to also think about the order. Like, do you first serialize a customer, or do you first serialize the product, or the order, or whatever that happens? It creates a lot of complexity. And at that time, event sourcing was new, and I'm a consultant, so we tried something new. And by the way, RavenDB also has replication, which looked very promising at that time, but it was pretty new, so we decided not to use it. This is how it works. Again, a lot of information in a lot of time, in only 45 minutes. So in this case, you have the same thing. This is a system. These are the projections, the query data. These are the events. And we, by the way, store blobs, big blobs, attachments and stuff. We store it separately. And then we have a secondary node. Can be a laptop or maybe a machine running on an oil platform. And what's cool about event sourcing is because this event store contains everything that happened in the order it happened. So if you then just say, okay, you know what? This is the first event. We just copy this event on this side and then project it into this side, in the query side. And then the next time, we take number 2 and then we take number 3. And if the connection is crap, if it just falls out or the connection is limited, those events, there's not a lot of data, it's just small pieces of JSON. We just track the number that we saw last, and then the next time we continue where we left off. That's simple. Again, this is a pretty niche solution, but it worked really, really well. And you can make it extremely reliable. Blobs we did separately, because we also had that situation that if a laptop was connected over 3G at that time, we didn't want to send over the attachment, we just do want to have the data. And by the way, sometimes because you could actually have conflicts, right? If the same, I don't know, this was a permit to work document, if they both have a copy of that permit, and they would both change it at the same time, you would end up with this conflict that I just showed you. We could have implemented event merging, but we didn't do that because we didn't need that. Because we had a situation where multiple people would never work on the same permit to work. So in that sense, and that's the little arrow on the top, we basically had a special API that the remote system could say, I want to lock a document. And every entity had some kind of owner that would make it possible that you can never actually change the same thing at the same time. But this all depends on the structure of your domain. Skip all of this because I just mentioned this. Challenges, yes. The domain. There's a lot of stuff you have to think about. Let's look at this application, for example. We're sending a command. Well, what your command will need to be handled, in this case, is the correct shipping address command, which actually loads a customer by its ID, some kind of technical functional ID, which is then triggering an event which is stored in the event store. Potentially, that same event is handled within the domain. And you actually, because it wants to react, it may want to, because the address changed for a particular customer, it may actually want to find all the orders for that customer and redirect them to the new address, something like that. That's a pretty realistic scenario. That's complicated. Then we have to find the order and maybe produce a new event. Well, this kind of stuff can become pretty complicated quickly because you also have to think about transaction boundaries and stuff like that. This is with a simple entity framework relation, you create one big transaction, you execute everything, and you're done with it. With event sourcing, it can be pretty complicated because typically you do not have transactions across different entities. You can, but it will severely limit the performance of your solution. So things to consider. What's important is, and that's something we did wrong, a command is basically a data transfer object. It's just a message that you send into the system. That basically means a message is valid, it's complete, and if not, you reject it, but it doesn't contain business rules. The business rules actually need to be in the handler. And we, especially in the beginning, we were trying to figure out, maybe you know the library called Fluent Validation. People were actually making those commands very smart because they're C# classes, putting all the business rules on that. Don't do that. It's actually making your life more complicated. You also need to think about, like, what happens if this event store becomes really big? You have millions and millions of commands, and millions of events. My recommendation is always try to identify some kind of functional partition key. Maybe your system is used in different regions, and people in different regions never work together, stuff like that. This is something you have to design from the start. Also, don't expose events outside your domain. That's an important one. Event sourcing is not a mechanism to distribute events across different domains so people can subscribe to that. Event sourcing is not what Greg Young would say, it's not a top-level architecture style. It's something that happens within a domain. So if you, for example, which is very popular these days, have a vertical slice architecture, people tend, if they want to use event sourcing, then start to use it everywhere. It's not like that. It's a pattern that you apply within a slice. Only if that slice requires that kind of complexity. And that's the mistake I made, by the way, because I used it everywhere. Because, yeah, if you have a shiny new tool, you use it everywhere, right? So don't do that. By the way, identity is not exactly the same as a functional key. You should probably use a technical key. GUIDs work really well, although GUIDs give the indication as if it's globally unique. It should be unique within that particular entity. It's a lot of details. Another thing that I made a mistake is that my events started to look like, stupid events that don't capture the business intent. They sometimes call that property change event. That was not the intention. They should actually represent what happens in the domain. And only use primitive types. Why? Well, if you actually use value types, custom value types in your events, and in 5 years, where your code base is completely different, you might run the risk that if you try to deserialize, for example, the JSON representation of this event back into this .NET type, that the rules for that value type have changed, and you suddenly have a production bug, because you cannot deserialize that old JSON into the new structure. That's kind of the complexity you have to deal with. Mentioned that already. Granularity, this will change. So, for example, here I have an example where we said, like, okay, sometimes we have this combination where we say we have a risk assessment, and when the risk assessment level changes, we have to either remove or add people to some kind of risk assessment team. We're talking about a business where people make mistakes, oil platforms can explode. So if a permit has a certain level, you need to make it very clear that a team has been evaluating the assessment. So what happens if a risk assessment has a level 2, you need a team. If the level is 1, you don't need a team. So what happens if you actually created a risk assessment, set the level was 2, you added the team, then you switch back to 1, then you have to apply all these events. Turns out that this was such a common thing, we made the mistake. We were treating these things as, okay, the level changed, a person was added to the team, a person was removed, which felt more like those property change events. Instead of that, we wanted to have, oh, there's even more, we want to have one event that really captured what happens. The risk assessment level was demoted or reduced or something like that. That is really what we intend to do. Yes, we changed the level and we removed some people, but with the events on the left side, you don't have a clue. Well, you do have a bit of a clue, but you don't know why we removed those users. You can deduce it if you would actually look through the history and saw that the level was reduced from 2 to 1, and then we started removing people from that risk assessment team. But with the event on the right side, it's much more clearer. This is quite common. This is one of the big things that costs a lot of time over the course of a big system using event sourcing. So what we have is, this is kind of how it works under the hood. We have a command service, which triggers a handler, which loads a customer from event store. It actually finds this customer created event, and then what we inject is an event converter. Sometimes it's called an upcast or an upconverter or something like that. And that class is a little C# class, understands how to treat those events. So it may actually split the event or merge a couple of events, and then it can even run, because this, if you do this at runtime, it can become very slow, of course, if you have a lot of history and lots of changes. An option is to actually do that during an initial migration. When you do an upgrade from version X to version Y, and it's a big upgrade, run the whole event store through this migration process so you don't have to do that at runtime anymore. May even change the identity, and then you have the new event, and then everything works as expected. This seems like a trivial thing, but usually you need a lot of plumbing. A good library for that can solve that for you. I already mentioned that, so for the sake of time, I'm going to skip some things. This has been the biggest Achilles heel of the system that I worked on. It always took too much time to make those projections faster. It always took too much time between when we upgrade, because we had this philosophy that when there's a new release of the product, we deployed it on the ship, and then the product itself was responsible for making sure that the database schema was updated, everything that was done at runtime. We didn't have database scripts or something like that. And I still like this model. My applications are completely responsible for the database schema. So you start it, and at startup, it will figure out what needs to be done. But with event sourcing, that can take a lot of time. So for example, we had a bug in production because, I don't know, a column was too small or something like that. We also decided at some point to restructure your projections. And because of that, the next time you release a new version, you have to redesign everything. Still have 10 minutes, right? Yeah. Maybe you build a new feature, a new screen, a new page. You need a new projection for that. So the next time you deploy the application, you have to actually build that projection. Well, there's a couple of things you can use to do to make it faster. This is the event store. You can have multiple projectors. And what's cool, because all these projectors are kind of autonomous, they are independently and specifically designed for different purposes, you can use a different type of database. This one is using a relational database. This one is actually using a document DB, like Mongo or RavenDB or something like that. If you make them independent and just make them asynchronous, that's what I usually do, then they can also decide, the projector can decide what's the best way to really build up that projection as fast as possible. You can even use different storage techniques, but also different caching strategies. Maybe this one, which is using raw SQL, uses some kind of in-memory or MRU kind of caching to make it faster. Like that one uses, what is it, owned by a projector, it uses a lookup to make itself faster. There's so many different ways if you actually take this approach where you can take a different solution depending on what you're trying to solve. Like, this is kind of a thing that I experienced, like senior developers like to choose one way of doing it and then doing it everywhere, right? And I've changed my mind over the time. I figured out that if you use the right tool for the right job, you're actually going to be much more productive. Consistency in a code base is something that I gave up. It's completely, it's almost like a dream if you want consistency, but it's not worth the effort. Here, you actually stop being dogmatic and actually choose the right solution to make it faster. That's what projections can do. And that's what event sourcing is doing. That's the powerful thing. We didn't do this, by the way, in the beginning. We made all the things the same way because it was easier for the new developers to start getting used to event sourcing. But that was kind of a mistake. We can even say that, for example, oh, by the way, you should not have dependencies between those projectors. Because if you make them autonomous, they may also project at different speeds, with different actuality, and you don't want to actually connect all of this together. So no joining, for example. One thing which we've done is that this projection that's being built here in this picture was caching at runtime was going to be dangerous, especially when you have multiple machines in a farm, you know, auto-scaling and everything. But we discovered that during upgrades, it's perfectly possible where we don't actually use that projection, you could use a completely different caching strategy to make this whole projection really fast. Again, lots of different ways of doing it. You can even, and this is a term from event sourcing called streaming, where you actually say, we're not actually going from the first event, second, third, fourth, fifth, etc. No, we're going to find all the events for a particular customer, a particular order, load them in one go from the event store, project the whole thing in memory, and then store the result in the projection. That's, again, you cannot use that all the time, but it's a potential optimization technique. This is how we do blue-green deployments. basically the same principle, what you can do with event sourcing. We have an event store, and we have version 1. And here we have version 2 running side by side with version 1. Because, and I didn't mention this, an event store is immutable. It's supposed to be immutable. So if you have version 1 running, version 1 will be writing events in this event store, right? Then version 2 is deployed. Version 2 may actually introduce new events. It can support any event that came from version 1. So whenever somebody is using version 1, version 2 is not available yet, it's just running in the background. It will just process all these events, build new projections. Yes, version 2 may actually write something back into the event store that version 1 cannot read. That's the easiest way to actually prevent that. And what we then use, I think the picture is wrong. Where is it? Yeah, the picture is wrong. What we then do is, in this case, we would actually use a network load balancer where version 2 will not be reachable, version 1 is reachable, and then when version 2 has completely caught up with everything that happened in this event store, so all the projections are ready, it will tell the network load balancer to switch over the traffic, which makes it possible to do blue-green deployments, basically with almost zero downtime. Okay, I'm going to skip a lot because, of course, I can talk about this for hours. The main question that I started with this talk to is, would I do it again? Well, I already spoiled a little bit at the beginning. For me, event sourcing is an architecture style. It's just like a design pattern, just like vertical slice architecture, onion architecture, clean architecture, all these things, they're just solutions for a problem. If you have the problem, you might consider the solutions, provided you understand the pros and cons. For me, event sourcing, I feel so comfortable with this whole solution, the way and the problems that you have to solve, that I would probably use it whenever there's a domain that's non-trivial. And that's important. I wouldn't use it in every part of the system, but if I'm building a bigger system, and whether it's a modular monolith, which is now very popular, nobody's using microservices anymore, I guess, there's always multiple domains in that system. Per domain, I might decide to use event sourcing, if it actually solves the problem that I have. I would prefer it over a more traditional CRUD architecture, because I've also built CRUD systems and experienced all the pains of using anti-framework or storing entities and trying to find the right balance between performance and protecting the invariance. I would use event sourcing. The question, though, is what kind of technology would I use for that? That's a bit of an issue. This is the whole picture again. There's actually different libraries. Maybe you've heard of MediaTR or Mediator. According to the author, it's actually MediaTR, like a pirate. He literally told me that. We actually were drinking whiskey, so maybe he was just making fun of me. Brighter is another one. This is more for command services. On the domain side, there's not a lot of options available. There used to be a lot of options, but all these projects have been discontinued. Eventuous is still the most active one. It's built by a couple of people from Denmark. They still haven't shipped 1.0, which I think means something. But yeah, it is very complete. There's a lot of documentation. On the event store level, so the one that actually stores the events, there's a couple of options. There's one that's very old, an event store, which was killed off at some point, but now it's being revived again, which is a small library to store events into different types of databases. MartinDB, maybe you heard of Jeremy D. Miller, who created a nice set of library, the Critter Stack. It's a good solution. And then you have Equinox, which is based on F#. I haven't tried myself. If I had to build a system in event sourcing right now, I would probably consider Eventuous, even though it's not like it doesn't have a version 1.0. It exists for a long time, and they're trying to encapsulate all the best practices from the community. The people that created it are also big speakers at all the DDD and event sourcing conferences. On the projection side, you have, again, Eventuous, because it tries to solve all these problems, including the event store. Propulsion, which is the counterpart of Equinox. It's also an F# project. And I've created my own library called Liquid Projections a couple of years ago, which I would still like to use because it's very simple. It's a couple of building blocks. But I'm also prepared, and that's something I would want to tell you, that you might actually have to build your own plumbing if you really want. You can start with Eventuous, but a lot of people that actually are successful at event sourcing build their own plumbing. And, you know, we're software developers, we love to build our own frameworks, right? So that's something to take into account. All right, I'm out of time. Oh yeah, this is a couple of examples with adventurers that you can see. They use a lot of C# trickery like records, like the with operator. I never actually used that myself. This is any event store as an example. Again, you don't have to remember that. It's just to demonstrate. I want to ask you to provide some feedback. If you have questions, you can use the QR code on the left. The QR code on the right is to say nice things about me. This topic is so big, I can easily talk about this for a full day. And you can see that because I already had to skip a couple of slides, because there's so much to know about. And depending on the experience level, yeah, there's so many things to do. I would actually recommend check out my blogs or approach me. I wrote a lot about this because I've made all the mistakes. I've shot myself in the foot, and I learned from that. That's how we become speakers, right? We try to share our own experiences. If not, I hope you enjoyed the day. I know it's the last session. There's drinks, and maybe I see you in the next conference.